Alright, so we finally get to work on the hallways. So, int, we're going to call it connect doors for now. And it will take two positions, position pointer door 1 and position pointer door 2. So that will be our function. Let's put it right under draw room. Return 1 on success. And we'll call it from create room. No, from map setup. We'll call it from map setup. So connect doors. And then the doors that we're going to connect. We're just going to connect this door and this door. So this is door 3 in room 1. So we'll pass it that as door 1. So rooms, it's room 1, so it's 0. Doors, and we said 3. Now one really quick thing is here what I've done is I've done top as door 1 and bottom as door 2, but I actually want to make it it's like 1, 2, 3, 4. So the top's door 0, left is door 1. So we're just going to switch these. So just copy and paste and switch the numbers. I'm not really sure why, just that seems, maybe the other way seemed logical when we coded it, but now it doesn't really, so. Okay, so this, we're passing it this door, and then we also want this door. So this is room 3, door 1, or door 2. So rooms 3, which is at 2, and doors 1. Okay, so this will be our example. Eventually we'll set it up so that it kind of automatically connects the doors, but okay, so we need to declare a new position pointer, and we'll call it temp. Ooh. Just thought of something. That could cause us some issues. Well, I won't worry about this right now. We won't worry about that right now. So temp. No, actually, we're not going to make this a pointer. We're just going to call it position temp. And then we're going to say temp x equals door 1 x, and then same thing for y. Now I'll tell you what I was kind of thinking there. I was originally going to make this a pointer, but then I think when we're going to be modifying this temp value, and I think if I had this as a pointer, then I believe what would happen is it would kind of overwrite door 1 unintentionally. I'm not 100% sure on that, but I think this way this will kind of avoid that. Okay, so we're going to have a lot of if statements here, nested inside an infinite loop. So while 1, I will always be true. Okay, so how this is going to work is we're going to start here, and we're going to randomly take a step in one direction. So say up, we're going to take a step up, and we're going to say, is that closer to the destination door? So if we're starting here and then we take a step up here, and we're trying to get over here, did we move closer to our destination? And if we did, is that space empty? So in the case of moving up, that obviously it's not empty, so we wouldn't go there. But then in the case of taking a step to the right, to this square right here, we would say, does it get us closer to our location? Yes, it does. Is it empty? Yes, it is. Therefore, we will draw a hallway there. And we're just going to do that until we connect. So that's a lot of if statements. So if, now what we're going to do is we're going to call ABS for absolute value. We take the absolute value of temp.x. So remember, the first time we do this, that's our starting position. Temp.x, take away 1. So the take away 1 would be stepping left. So let's call that a step left. Minus temp.x. And we're going to say, is that less than the absolute value of, sorry, not take away temp.x, take away door2.x. And we're going to say, is that less than the absolute value of temp.x, take away door2.x. In other words, we're going to say, if we step here, does that move us closer to our end location? Or does it move us further away? Or no change? And then we also want to make sure that that space that we're checking is empty. But we're only going to check if we've already determined that gets us closer. So and move inch. So then our temp.y for a y location and temp.x minus 1 for our x location. We're going to say, and that is equal to a space. So we're getting the character that's at this location that we're trying to test, and we're seeing, is it empty? If it's not, if it's anything else, then we're going to assume we can't go there. Okay, so if all that is true, then we will move print w. We'll go to temp.y, temp.x minus 1, take our step to the left, and then we will print our hall symbol, which is going to be the pound. And then we will update temp.x to equal temp.x minus 1, and y is going to stay the same in this case. Okay, then we're going to do the same thing, but we're going to step right instead. So this is an else if, by the way. Yeah, that's how I want it. So step right. So the only thing that changes here is we're adding 1 instead of taking away 1. So everything, all the logic will be exactly the same. But instead of subtracting 1 and going to the left, we're adding 1 and going to the right. So just make sure you change all those minuses to pluses. Okay, now we're going to do the same thing but we are going to step down. So now we're dealing with the y coordinates. So the x coordinate stays the same, and we're just dealing with the y coordinate. So here it's +1, and here it's just the normal x coordinate. +1, and we're modifying the y value instead of the x value. And then step up. So again, here we're just changing the plus to the minus. -1, -1. Okay, and then else we're going to try all those steps, but there might be a time where we just get stuck. So in that case, if we can't move closer to the destination, we just return 0 for failure. Okay, now I'm also going to add a get char function call here just so we can see it go one by one. Okay, let's just run that, see how many errors I coded in there. Okay, main 198. So these are dynamically allocated, so that all needs to get changed. Darn. That's something that kind of annoys me about C, is just something like that, you know, a little error like that would never happen in Java, but C is a good language, so let's clear this. Try again. 198. So here, oh, I have an extra comma, get rid of that. Try again, same thing. I just copy and pasted, so makes sense. Okay. Well, it compiled without any errors, so let's see if we got our logic correct. So here it's starting to print out the hallway. Now we just need to press a character to keep it going. Alright, so this hallway connected. Now it won't always work. Let me try and find an example where it won't work. This will work. Okay, here it shouldn't work. So it's going to keep going, stepping to the right, and that's always going to make it closer. But then when it gets here, or is it here? Yeah, here. Now one more, it needs to go up, right, at this point, and one more step to the right is kind of the wrong direction, but it does move it closer. So it takes that step, and then it's just, it can't go up anymore, right? So it just stops. So that's a bug, but you know, there's more bugs, so that's not a problem. Yeah, we can't walk on the hallway yet, but let's just quickly change that for fun. So in our handle, in our check position function, we're just going to add two cases here. So one's going to be the plus, and one's going to be the hallway the door and the hallway symbols. So just again, that's where the hallway gets stuck, but we can walk on it now. So it does try and go up. Okay, here. So we can now go from room to room, which is pretty cool. So we'll work on some of these bugs in later videos.